Yeah, now you can.
Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. This is Ahmed Hijazi, CAD Solutions founder and SEG Software owner. Inshallah, today we will present SEG Software as one of the most important solutions for 3D modeling and detailing of static. I received yesterday evening from Fauzan a sample, and I would like to make a demo for it. It's for a tower, and in this presentation, inshallah, I will show you how to make a model for your equipment by using the exported MDB file, which is a database file from BVL. Okay, let's start with this one because it's a tower and it may take a little bit of time. So here we have SEG software, and from here we will start a new model demo. Okay, we will start a new project, and from here we will select the location of this project, and now we will create. Here you can figure that you have the ability to select between different modules for overall module, which include all features, and heat exchanger module, vessel module, ducts, storage tanks, and piping. Here we will select the overall module and click Finish. After this step, after creating this project, we will import the Access database file to our model. From here, we will select on this one, on the vessel, and from import, we will select Import Access file. And here you can figure from this dialog box, you have some steps to do and some notifications you should take care about it, and we will discuss it after creating the model indeed. Now we will import the Access database file. So from here, we will open the folder and select the location. Here, that's the MDB file. We will import it and click Import. Now, SEG detected that this vessel is a vertical vessel, or this equipment is a vertical equipment. If you would like to change the orientation of this vessel, the position of this vessel, you have the ability by clicking on No, but we will accept this position, so we will click on Yes. Okay, after that, SEG will detect all information inside this MDB file, and we will get some messages like this. Now SEG detects that we have a shell course. If you would like to modify the orientation of this shell course, just you will select this shell course and modify the orientation of the welding line like this. But right now we will accept all the next elements like this. Click Save directly. After that, we could define it. Here, we SEG detected that we have a stiffening ring, okay, but no information in the MDB file regarding to this one, like type. And I will show you this point in the exported MDB file because this MDB file have some shortage in information. Okay, now we will click Save and continue importing data by the same way. It's a tower. It includes more than 150 elements, but you can figure that after importing the elements to SEG, inshallah, it will not take a long time to create it on as a 3D model and a detailed drawing. Okay, now we have this tree. This tree includes all data in the MDB file, like the elements which we have a bottom head. This bottom head includes a nozzle and a skirt. Okay, all of those information. We will select the vessel from here and save tree. Okay, this step takes around 1.5 seconds for each element to save it. So if we open this switch for this stopwatch and calculate the required time to save this tree. This tree includes more than 80 elements. It's around 85 elements on this tree. If we calculate the time required to save this model, 1.5 right? It's required 2 minutes, around 2 minutes to save this model and save all information of this model. Now let's open this presentation of SEG, and let's introduce the SEG software. It's an engineering application software. You can use it to make a 3D digital prototype for static equipment like pressure vessels, vertical, horizontal, and multi-sectional sections, columns, heat exchangers, storage tanks, ducts, and storage tanks with a fixed roof. So you have the ability to create a wide range of equipments by using SEG software. By using SEG software, you can save more than 80% of your time and money. How we can do that? We make a comparison between AutoCAD and CAD software like Autodesk Inventor or SolidWorks or CATIA. The third way in comparison, we make the model by using SEG software plus Autodesk Inventor. In this comparison, you can figure that by using AutoCAD, we consumed around 60 hours to create the 3D model and the detailed drawings of this equipment. All of those drawings. By using CAD software like Autodesk Inventor or SolidWorks, we consumed around 35 hours. By using SEG software, we consumed around 8 hours only. So you can figure that easily, that you can save time and money. Okay. So from here, you can figure that we have different types of equipments you can generate it by using SEG software, as we discussed, vertical and horizontal pressure vessels, storage tanks with a fixed roof, columns with multi-sectional sections, and ducts and piping. Okay, let's come back to our model here. Okay, we still saving the items. We consumed around 2 minutes. Maybe that because I'm recording this session and that takes load from the memory. Okay, let's come back to the presentation here. And you can figure that those are a real model we created by SEG software for storage tanks with a fixed roof and spiral stairs, the arrangement of roof plates. Here, complicated pressure vessels with a piping inside and outside, and common configuration of shapes like davit or enclosure, like this. Okay, heat exchanger, many types, and inshallah we have a webinar this next week, inshallah, for heat exchangers. Okay, now let's come back to the model. Okay, so I need to stop the record because it consumes the memory. Sorry. I hope, Fazan, that you can record this session. Okay?
Yeah, we are already recording the session, so no need to worry. Okay.
Okay. Okay, now
I hope Kaustuv recording is started.
Yes. Here, after saving the model, we will make some modifications on the skirt, and I will tell you why this modifications takes place. Here, I will modify this according to the Access database file and define the length of this one. Now I will start creating the model of the this tower. From here, I will open the assembly and click Start Assembly to start the modeling of this equipment. It will take around 9 minutes because we have in this model, after creating it, we have more than 150 elements, and this model takes between 9 or 10 minutes. Now we start modeling this this tower. Here the model shall be created on Autodesk Inventor. Each element of those will be created on Autodesk Inventor automatically and created automatically, and the assembly will be assembled each item by item automatically. Now let's complete our presentation here. Okay. Some important information we should fill it during our project, like the project data, project name, project client, the owner, location, manufacturer, and other data from the project level. We have 3 different levels on that SEG tree. The first level is the project level. The second level is the equipment level. In equipment level, we need to define some information like design data of this equipment, design pressure, temperature, design code, construction design code, and many other information for this equipment, and the position of this equipment. By opening the setting of the equipment, you have the ability to define the position of the vessel, if it's a vertical, horizontal, or sloped vessel. Define the delivered blade dimensions here. By defining the delivered blade dimension, by using those values, SEG will calculate automatically the required item of blades needed to create the total circumference of the shell. You have the ability to define the units that you will use it in your model in millimeter or in inches. And by using SEG software, you have the ability to create all parts automatically, assemblies, and you will get your complete bill of material for your equipment. You can generate many other features like nozzle opening, sheet metal flat pattern for all blades in your project, and you have the ability to export the 3D model to many different extensions to suit the other CAD softwares like Pro Engineer, CATIA, CAD Works, SolidWorks, and more. The same for drawings. And the same for sheet metal flat pattern. You have the ability to export it in DWG and the DXF extensions. Okay, we have an SEG software, a tool for making the bottom and roof arrangement. By using this tool, you have the ability to arrange plates of the roof and the bottom easily. By making some arrangement of plates, dividing, moving left to right, and we will discuss that in the next slide. For the storage tanks, you have the ability to create radial roof, arranged plates, dome roof, bottom plates, annular plates, spiral stairs, clean outdoors, and manways. And in this small video, we will create a roof with 42 meters diameter. Okay, and here we generate the project, and from here we will define the delivered blade dimensions, and you can figure that easily by defining the dimensions of this delivered blade. We will use it in a calculation. Now we will define, we add a radial roof, and it defines the slope, the diameter of the roof, and from here we will make arrangement of plates automatically. After that, you can modify on it, like dividing the plates or rotate the blades from the horizontal position to the vertical position, and make splitting on plates, and defining the width of each plate. Okay, defining the orientation of the welding lines of the plate. Okay. And after that, you will send this information to Autodesk Inventor to create it easily. All of those information are saved in your project. Anytime you have the ability to modify and edit it. Okay, now we will make some adjustment for plates like this, and change the orientation, and from here we will click start. Here in Autodesk Inventory, you can figure that the assembly shall start like this, and the blades arranged in the same way and the same dimension you modify or you defined it in SEG. Okay, and you will get a complete bill of material for all blades, and by those plates you can make after that, make a nesting, and we will discuss this point here. That's a complete bill of material for the roof. Okay, by using SEG software, you have the ability to create all sheet metal plates in your project. And by using Autodesk nesting tool, you can generate the nesting blades for all of your project. And you can imagine how you can save time and money by using this tool. Okay, let's give a sample for that. Here for this storage tank, we will open the annular plates and make the nesting for this annular plates, just opening the assembly. And from here, we will create assembly and click yes. Okay, now this tool of Autodesk will detect the thicknesses and the material for all plates, and if there is a different material or different thickness, it will separate it on a different sheet plate. Now, after importing this one, we will define the available plates in the stock from the market. After that, we will make a nesting. Okay. Here you can figure that by making a nesting, we will need 3 sheet plates. Each sheet plate includes 4 elements, and after that you can make more and more. Here we have a tool for integration tool. This tool for deals with HTRI software, which is thermal heat transfer calculation for heat exchanger. After exporting the CSV file from HTRI, we can read this CSV file to make the tube bundle arrangement for tube holing. Okay. And inshallah, we will discuss that indeed in our webinar next week, inshallah. And we have a special tool for making the hole better. And here you have the ability to select the tube layout and the location of the tube arrangement on the vessel, select the pass partitions, and many different options to make your arrangement of tubes inside the tube bundle. Okay, here that's a small video for that. We will define the heat exchanger inside diameter, tube diameter, pass partitions. Okay, select the pass partition, the whole tie rod diameter and ceiling rod diameter. It's just a quick video for that, and we will discuss all of that in deep, inshallah, in our webinar next week. Now, after creating the arrangement of tubes, you can figure that the tube number in each group, and you can modify the pass partition location. Okay, and you can get the correct or near number of tubes in each room. Okay, that's another tool in SEG. And by using SEG, you have the ability to create a detailed bill of material for your equipment, and you have the ability to export it in Excel format. If you have another department need this Excel to make some information, and you have the ability to create material cost report for your equipment by defining the price of each material per ton, and you have the ability to export it in HTML format. Another tool in SEG for nozzle holing. By using this tool, you can make hole opening on the sheet metal. If you would like, after that, to make a sheet metal flat pattern, so you will need, in this case, to make the opening of nozzles on your sheet metal. So by using this tool, you have the ability to make the cut on nozzles. Another tool for automatic creation of the sheet metal flat pattern for each sheet metal plate in your project. And by using this tool, you have the ability to export this model to DWG extension, DXF extension, and exporting it for nesting. The tool that we discussed it from slide before. Here in the exporting of the 3D model, here you can export the 3D model in many different extensions like DWG extension, DXF, step file, STL file, IGS file, SAT file, many different extensions for the 3D model. And regarding to drawings, you can generate your drawings and export detailed information inside it. Many tables like nozzle table, and this nozzle table includes all information about the nozzle, like the nozzle tag, nozzle service, nozzle size, outside diameter, thickness, schedule, external and internal projection, reinforced band information, and the welding detail, and the connected flange. Here, after that, you have the ability to add your border to our database, so you have the ability to use it anytime. And in drawings, you can add standard welding details from our library. We have a huge library for welding details, so you can select from it to generate your drawing. And here, that's the integration to a new tool in SEG. It's just a tool. We have many different tools in SEG software, and that's just a tool. You can use it to speed up your work by exporting the MDB file from the BV Elite. Okay, we will use SEG software to generate the 3D model of the equipment. After that, generating the general arrangement drawing and the detailed drawings for this equipment. Okay, and that's a small video for that. Okay, and now let's check the model of the equipment. Now we have the complete model of the tower that we did by using SEG software for the equipment. Now we will make some adjustment or some customization on this model. Now we have nozzles, shell plates, and other attachments. Okay, you can figure that we create this model in minutes. And now we will make some customizations, like the nozzle, bottom nozzle here. In the access file, no information about the connection. Like we have an elbow, for example, and after that we have a pipe. No information on the MDB file about that. So we will make that from here by SEG, and SEG gives us the ability to do that easily. From here we will select this connection, and from here we will select elbow, O to elbow. Okay, and let's define the type and the size of this one. From here we will select this elbow and select the size 10 inches, and the thickness is 14 millimeters. Like the flange, which we imported here, it's 20 inches and for 14 millimeters. So we will change the size here, make it 20. Okay, and let's add another pipe. So from here we will add a pipe, go to pipe. Okay. And from here we will select this pipe and change the size to 20 inches and define the thickness and the length of this pipe. Click Save and click Start the assembly. And here we will update the model and make the modification on this model. And you have the ability on the setting to make a preview, or you can see the model during creation, each element during creation, and I will make this option here. You can figure that we add this elbow and pipe, but you can figure that the flange is still on place. The right arrangement of this one, that the flange comes after the pipe. So we will move this flange after the pipe. So we will move it after the pipe. Okay, so we'll move this flange after the pipe from here. And just make so the arrangement, the right arrangement of this nozzle, elbow, pipe, and flange. So we need to make update for the model like this. Okay, and from here you can figure that the right connection comes like this. So by using SEG tool, we have the ability to make a customization for the elements of our equipment. For example, let's change the projection of this nozzle. So if we select this nozzle on the top head, this one, and open the calculator, which calculates the projection from the seam line. So we will define this value as 1200 and calculate the projection of this pipe to adjust the facing of the flange from the seam line of this head. Okay, now the pipe projection will be 344 to make the projection from seam line to flange facing. So we will change it a little bit like this. Okay, the projection will be 184 and click Save. Now we will click Start the assembly to modify the projection of this nozzle. Okay, so if we measure the distance from the facing of this one, if we measure the facing from here to there, it's the same that we defined on SEG software. Okay, now we will make some modifications regarding to the head right here, because this formed head is with a large diameter, 4 meters diameter. So it will not be from one piece. So if we need to modify it after importing it from the PV-Elite. Now if we select this head, which is the bottom head, you can figure that you can make it from one piece or 2 pieces with seam weld line like this, or you can make it from segments like this figure on the right hand side. And let's define the inside diameter of cut right here and the weld spacing, the first longitudinal welding line orientation, and the required segments for this head. Let's make it from 5 segments and click Save. Now we will click Start to start creating this head from elements. And I would like to make the option of a preview of elements during creation because it will give you a good indication or indication about the element during creation. Here from SEG, we will go to the setting of the equipment, and from the app setting, we will select child preview and parent preview. Both of them will give you the ability to make a preview on Autodesk Inventor for elements during creation and make this normal zoom in Autodesk Inventor. Here you can figure that this head we make it from segments. If we open this head here, you can figure that we make this head from segments, and each element you can open it separately. Okay, like this. So those are the segments of the formed head. So by using SEG, you have the ability to modify and make a customization for your elements after importing from SEG. Now let's make a modification on the shell course, the first shell course. But before that, we will make a preview for that and click Save the setting. And from here, we will select the first shell course, and you can figure that it's automatically calculate that we need 2 shell blades, okay, and we need this slice here to complete the shell circumference. The first slide is the same delivered blade dimension, which is 12 meters length. Okay, if we open this one, for example, that's the first shell, and if we create the sheet metal flat pattern of this one and measure the length of this one, it's 12 millimeters. This is the same defined dimension here for the delivered blade dimension. If we open the setting and select the vessel, and from here the equipment setting, that's the length of delivered blade dimension. Okay, now let's come back here and make this shell course from two equal pieces. And if you would like to make it from different lengths, there is an option on the shell to make that. You will find the different types of shell. You can select between them. But here we will make it from two equal segments. So we will click Save and click Assembly. And here we will update the shell plate. You can figure that the shell plate will open on a separate document, and you have the ability to make a preview for it during creation. That's the options that we talked about it. And here you can figure that you change the welding line orientation of the shell plates and make it from two separate plates like this. Okay, two equal plates. Okay, now we will add some attachments to this manway, like bolts and hand grip and davit. Now we will measure, the required length of the bolt. Okay, so we will go back to the model and we will select this manway, which MH6, and select the blind of this manway. And from here we will add hand grip, MH6 grip. Okay, and click Save. And from here, we will define the grip dimensions. We need to define the spacing orientation and click Save. Now we will add a davit. So from here, MH6 davit. And from here, select the required type of the davit. Let's select this type of davit and define the orientation and opening direction. And from here we will add a stud bolt. So H6 stud and click Save. From here we will select the size of the stud bolt. And click Save. Now we will start the assembly. To start creating all connections to this manway, like hand grip, stud bolts, and davit. And you can figure that from this option that you have the ability to make a preview for each element during the creation. Okay, let's come back to our presentation here and some customization for some elements like lifting lugs. In SEG software, you have the ability to add many different types of lifting lugs, and you can figure that you have a variety on selection, and each type of those have many different options that will give you a wide range of selection. Here, for example, the first lifting type, here you can use it in a longitudinal direction, and you have the ability to move the hole from left to right, and that will give you some options. You have the ability to add coolers and wear plate, the same for the other lifting lugs, this one for circumference direction. You have the ability to add wear plate, coolers, stiffening grips or not, so it's optional, so it will give you a varieties in selection. This type of lifting lug is usually used in large diameter horizontal vessels. Okay. And that one for mostly for vertical vessels. And in this type, you have many different options, like you can make the end with a fillet like this, or with a chamfer like this one. And the same for the end right here. You can make it a straight end, or you can make it with a fillet like this, or a cut like this. And you can make this cut with fillets like this, or with sharp edges like that one. You have the ability to add a cooler or ear plate, or weld the lifting lug directly to the shell plates. This type of lifting lug for small vessels, those types for shell. And you will find more types on head and blind flange, like lifting lugs which welded to the blind flange. We usually used in heat exchanger or larger diameter blind flanges. Okay, this type of lifting lug. And another type was the cross lifting lug. It's usually used there when we need to lift the equipment from one point. We need this type of cross lifting lugs. And the trunnion, by using this type, you have outer ring or outer end plate. You have the ability to add it or without it in these two cases. So it's an option. The outside rings, you can add one ring or two rings like this case. The same for inside ring. You can add one ring or two rings or without any inside rings for this trunnion. This type of trunnion. Okay, let's come back to our model. Here we have this blind flange with davit and bolts like this. Let's add a platform for this one. So let's select this shell course, and from elements we will select a platform, and from here we will select platform 1. Okay, and let's define this platform. So we will select the vertical platform and define the clearance between this platform and the shell. Define the width of the platform, the height of rails, the start angle. Let's start from 44 and end to like this, and the location of this one. And let's add a ladder and kg for this ladder. Let's increase the length of this ladder, for example, and click start, and come back to the 3D model right here. Okay, now we have this platform on the equipment, and if we need to add some platform clips or ladder clips to this equipment, if we come back to SEG Software, and from here we will select the parent element, and from elements we can add external connections like platform clips or ladder clips. For example, let's add a ladder 1. From here we will add, from this clip we will add a wear plate for this clip, add a slot hole, define the length, width and location. Let's make this location at, let's say, like this, and the orientation, the same orientation of the ladder. So let's come back to here and check the orientation of the ladder. So it's the same orientation, and now let's click start simply. And now we have this clip on the shell here. That's the clips. Okay, right here for the ladder. Okay, with defined dimensions. And now I would like to show you some important points on the MDB file. If we open the MDB file right here, and check the stiffening rings, because in this model we have stiffening rings, but the exported MDB file not include information for the shape or the type of this stiffening ring. And you can figure that during importing, I select external stiffening ring and make it a ring. But here, all information here, it's a application section, no information regarding to the shape of this type of stiffening ring, if it's T or I or H or angle, no information regarding to that, just the location of this one and some information regarding to inertia and the area, not regarding to the configuration. Now we will make that here in SEG. So we will select the first ring 1 of 5, and you can figure that the imported information is 0, 0, and that's the location 1850. So we will make that one as a built-up section and make the same location, change the same location, and define the dimensions of this cross section of this stiffening ring. The same we will do it for the other stiffening rings. Data location, and for example, click save, and let's select the ring 3, defined the same location. Okay, ring 4. And still we have one ring. This is stiffening ring. We have ring 5. This one. And this stiffening ring, the last one. And let's start the assembly. Here I would like to notify for some important points during the importing of or exporting the MDB file, because some users export the Access database file in a wrong way, so they will get wrong information because they give SEG a rubbish information, so they will get a wrong model. So how we can export the Access database file from BVLit in a correct way? Okay, in this next slides we will discuss this one. During importing SEG, during importing the Access database file to SEG, we informed you that you should make some steps before exporting your model to Access database file. The first one is the unique names. Okay, unique names means each element in your file or in your BVLit model should have a unique name. Why? Because in all CAD softwares, if you have a project, and you should have a unique names for each element in your model. No repeated names, because in the 3D model, when you open it, the 3D model will get a deflect or between the names. So you should have a unique name for each element. That's the first point. The second point, before exporting your model, you should convert all units to millimeter. Okay, the length dimensions to millimeter units, no inches. Okay, you should export it in millimeters. After that, you can make it again to your units, but before exporting, you should make it in millimeters. The third one, which is the nozzle size. The nozzle size should be defined as imperial, ANSI imperial, not in VIN. like it should be 2 inches, 4 inches, 8 inches, not 20 millimeters or 50 or 600 millimeters for 24 inches. So you should export your model after changing the size of nozzles in imperial unit. The last point, which is the characters, okay, and we will discuss that on the next slide. When I received the exported Access database file from our customers before this presentation, I found that we have repeated names on the main elements. The main elements table includes the main elements of the equipment, like shell, head, cone, all of those elements, flanges. So I found that we have repeated names. If you take a look, we have 5 elements with the same name, which is a skirt. We have 2 elements with the same name, which is shell 2. We have another 2 elements with the same name, which is cone. So I make a modification. So on the right hand here, we take a look. We have those elements with the same name, those elements with the same name, which is shell 2, those with the same name, which is cone. I make a modification, make a 1 element as a skirt, and modify the names to make them a unique names for the main elements. The same problem I found it on the stiffening rings. We have here the same stiffening rings, the same trays with the same name, and that will cause a big problem in the CAD software and the SEG software too. So I make a modification for names and make it a unique names, no repeated names. The same problem I found it on the stiffening rings. Here you can figure that the same names for stiffening rings. So I make this modification for names. For nozzle sizes. When I received this file, I found all nozzle sizes in millimeter or in din. So I converted to inches. So we notify this for our customers. You should export the MDB file after changing the units and the nozzle size to be in imperial format, not in din format. So I changed that to be imperial. Okay. And the characters. The name of elements shouldn't include those characters. Those characters causes a problem in database, in our database. So you should avoid making those characters in your in names of elements. Okay. So those are the 4 steps to make a correct exporting for the Access database file. Those 4 points: unique names, units, nozzle sizes, and characters. Okay, so let's come back to the model here. After modifying the stiffening rings, we have the correct stiffening rings here and there. Okay, now let's create the drawing for this equipment. And here I will change this view to be a front view to make this view on the drawing on that one. And let's come back to the model here, and from visual we will select the equipment, and from drawing we will select drawing and select create drawing. And from create drawing we will select the size of the drawing. Let's make it a 0 and a node, and from here we will select 2 sides. The first side, which is division. Sorry, let's make it all capital. Okay, and from here let's make this and back view, our bottom view, and from here let's select this view, which is the left view. So that view, which is the left view, will be our elevation. Okay, and the back view will be that one. Okay, so let's come back to the model and complete the information. And from here we will make the scale of the equipment, and we will export the bill of material, design data, nozzle table, flange table. We have a fitting, a gasket, pipe, and the nodes. Okay, regarding to nodes, we have a standard nodes. If you would like to delete or edit, just click delete to delete the ones that you would like to delete it, or make edit for if you would like to add, for example, add new node and just add it. right here. And if you would like to edit or delete or modify, if you would like to edit this node, for example, just click edit, and you have the ability to edit this node right here. Okay, and if you would like to import the nodes from Excel file, you can import it by using this tool, which is import from Excel. Regarding to the welding details right here, we have a library for standard welding details. You can select from it like this. For example, select the required details for your model. Okay, and click Save. And now we will update the revision table. From here, we will review and add more rows in the revision table. Let's delete this one. Okay, and define the drawing name, the drawing number. Okay, and from design data here, if you would like to separate some tables on another sheet, you have the ability to do that by selecting if you would like to make it from one sheet, two sheets, or three sheets. But right now we will create the drawing. Let's click on create drawing. Here, the drawing size will change it automatically. Okay, and the views of the tower will be added to the model. Now the revision table. After that, the bill of material. Here, and it will be added automatically on the right place on the drawing. In this drawing, after creation, I will modify the size of this drawing because a node is a little bit large. We will modify it and make it A1 in A1 size. Okay, and change the location of tables manually if we would like to change the location of tables. Here, after creating the bill of material, you will figure the number of elements in the bill of material. I will show you that it's around I think more than 200 elements in this top. So you can figure that it's a big model. It's not just a small demo. It's a big model. And actually, if you would like to make it on any other software, you will consume the days and days to create something like that. But here in SEG, SEG will save time and money for you by make everything automated. You just import the MDB file from the BVLit, and now we generate the 3D model. And right now we are making the automated drawing for our equipment, and you can figure that now we have the bill of material automatically. And if we take a look to the number of elements in this model as inventor elements, we have 275 elements in this model. Okay, all of that generated automatically by SEG. Okay, if we make an extend, now we have the design data nodes that we defined. Now we have the nozzle table of this equipment. Okay, if we take a look to the nozzle table, okay, many different tables, and each table include a lot of information regarding to your model, like gaskets required, flanges, pipes, fittings in your model. And if you would like to export the nozzle loading to your drawing, you will add a load for the required nozzle, and by using this you have the ability to export the nozzle load table. Now the welding details to the drawing like this. The selected welding details that you selected from the model will be from our library or SEG library. It's at here. And the information that you defined, like the drawing name, vessel name, and manufacturer, all of those data shall be reflected automatically to your title block. Okay, so by using SEG, I think we start from 45 minutes ago, and in this time we generate this tower, okay, and generate a general arrangement drawing for this tower, and we just need to make some adjustment for the drawing size and add some dimensions. Like we would like to add a nozzle tag, for example, for this nozzle. If we would like to add a nozzle tag for this nozzle, automatically SEG will detect the name of this nozzle because you defined it on in your model, which is a node name, so like that. And if you would like to add a reference point, let's add the turn line here. And add a datum at this point as a datum point to measure from here to there. Let's continue like this. Okay, and if we have a nozzle and if we would like to add a datum for this nozzle, it depends on here. So that's the location of this nozzle. And we would like to add a name for this nozzle just like this. So you have the ability to add dimensions for your model in minutes. It will not take more time from you to modify or update this like this. Just let's say 15 minutes in this tower to add all of your dimensions or required dimensions here and there, like for example inside diameter here, like this, thickness, like that. Okay, one more point I would like to discuss it here, because when I checked this model, I found a point regarding to the wrong data, not correct data on the model. Here on the conical section here, the dimensions of knuckle radius and small radius, those dimensions are not logic. If you would like to draw it by AutoCAD or by hand, or those dimensions will not give you the correct shape, because it will make a conflict. It will not be a correct. So I make a modification before creating the model on those values. So let's give you a sample. If I open this cone, for example, okay, and go to the sketch, which we use it to draw this cone, this sketch here. Okay, this value here on the received access database file, it's 400, and for this one 360. If we would like to change it, let's make it. Let's add more like this. Okay, but if we would like to change this to that value, which is 330, like this, it will not be changed. You cannot make it like this. You will get an error. Okay, if you would like to change it. So if you would like to change it again, inventor will not accept this value, because this value is a wrong value. It will not give you a correct shape or correct configuration. So you should be sure if you have an error element, you should be sure that you make the right or the correct logic dimensions to get your shape. Okay. Any questions right now after making after that? Any questions, Fawzan?
No,
let
thank
me
you.
check. Okay. Saurabh ji, do you have any questions? Anybody else having any questions?
Actually, we have 2-3 questions, Fudan. First was
Yes.
regarding the requirement of non-standard flange as girth flange to the column. Is that possible?
Okay, regarding two non-standard flanges, we in SEG software here, if we let's add an element, let's add, for example, on this nozzle, let's add a non-standard flange. So from here, you will find that design the flanges. So if we select on design the flanges, let's name it as F1, okay, and click save. Here in F1, if you select it, you can figure that you have many types of non-standard flanges. You can define, you will find a wide range of non-standard flanges. Just select the required shape and define your dimensions, like integral weld neck flange, integral weld neck flange with grooved face, not raised face, flat face or ring joint. Just select the suitable shape, slip on and integral ring, integral slip on, just select the required shape and modify your dimension. You have the ability to add a guiding pin, jack screw, or vent hole to this flange for this non-standard flange. Okay, for jack screw, for example, changes the size, and if you would like to make it as a user-defined, just click on user-defined dimension and modify the size of jack screw manually. The same for vent hole. If you would like to add a vent hole, just select the standard sizes, one of the standard sizes. If you would like to modify it manually, just select user defined and define the dimension of this vent hole manually. Okay, let's come back to the main elements tab here. From the main elements, you can figure that you have many different elements. You can add it as a main element, like head. In the head tab, if we select this head, for example, you will find more than 70 elements or different elements of heads, like conical head with closed end, conical head with knuckle radius at the end, hemispherical head with negative straight flange, which usually used in Division 2, convex head, standard CAD, many different types of head. That's for one element, which is the head. And the same for shell blades, for example. If we select the shell element, you can define it as a vibe or as a shell, but without any welding lines, if you would like to make something like that. Or you can make it shell from different pieces. This type, we usually use it on storage tanks, because in storage tanks, you may need to define each blade separately, the length of each blade or the circumference of the tank separately. Threaded pipes, many different types on shell. And if we come back here to the elements of here, you have the ability to add a chamfered blades as a vibe or as a shell blade, concentric and eccentric cone from blade, standard flanges, designed flanges, blinds, different type of standard blinds, connection flanges, two flanges with a gasket automatically, tube sheets. If you would like to add a gap between elements, standard fittings like standard cones or standard reducers, elbows, T, plugs, gaskets with pass partition for heat exchanger, expansion joints, Y joint for heads. For Division 2 calculations, you may need sometimes to make a Y joint, valves, manometer, pumps, end closures, agitator, end blades, sections, and elements for ABI storage tanks like dome roofs, ducts, many type of ducts. Here, by using SEG, you can create many different type of ducts and custom items. For example, if we select a shell, for example, you have the ability to add many different childs to this one. For example, for this group, which is a support group, you have the ability to add saddle, stacked saddle, legs, lugs, skirt, anchor chair, many different type of cradles, and nozzle openings like nozzles according to SME or API with internal projection or without internal projection, couplings, clean outdoor, welded stud outlet. For the lifting lugs, we discussed the lifting lugs, external attachments like nameplate, a grounding lug, external reinforced bad stiffening rings, ladder clips, nozzle support trips, insulation rings, platform supports, ladders, and nozzle supports. The same for internals, deflector, impingement baffle, demister, stiffening rings, trays, platforms, and coil and half pipe.
Can you show us the demister attachment once?
Okay, let's check a point regarding to the support saddle. Here, if we that one, support saddle. Here, if we take a look for one of those elements, like the support saddle, here we have four main types of saddles. The first type is a saddle with outer ribs, and the mid rib or mid rib is without any edges. The second type, if we take a look at this, here we have this edge right here, but the first type not include any edges here, and the edge on the second type goes to the center of the equipment. On the third type here we have this type of saddle. The web has a straight edge like this, goes to down to the bottom, not to the center of the vessel. The fourth type has a lifting lug, and this type, one of our customers in USA asked us to add this type because they are usually used it in heat exchanger. They are lifting their heat exchanger by using this type of saddles. Okay. And each type of those has three different cases. The first case, the web on
Ahmed,
the middle.
Ahmed,
Okay.
actually, customer is asking to show demister and trays. Can you show that through software?
Okay. Okay, here let's add a section, view. Okay, but I'd like to inform you that it's not a detailed demister. It's just for your drawing, not a detailed demister. It's just to indicate that you have a demister on that level in your drawing. I will show you this point here. Regarding to demister, for example, let's add a demister on the last shell course. So let's select the last shell course here, which is that one. And from elements, let's add an internal demister. And click save. And from here, let's select this type of demister. This type of demister, we have a demister and stiffening ring with support plates like this. Defined the height, clearance between the inside diameter of this demister and the shell. Defined the material. By the way, clearance of the model. Define the location of this demister. And define the dimensions, number of clips, angles. Okay. After that, you will click save and start the assembly of the model. So if we come back and make a section again, here, let's make this section. Okay, now we have this demister right here. So you can indicate the location of this demister here on your model, that one. Okay, so you can indicate it on the drawing, indicate the location and all of that. Okay, and regarding to the supports and all of that, the bill of material will be calculated automatically for that one. And if we open the tables and if we click on bill of material right here, we will get a complete bill of material for our equipment. That's it.
Ahmed, there is one more question.
Yes.
Is it possible to add EIL standard request, such as EIL type of saddle, demister, or any other EIL specific items which they are actually dealing with? I think it is customizable, right? So
Yes.
we can customize the saddles as per their requirement, right?
Yes, you have two options. The first option you can, and that's the first one, you can create this item on Autodesk Inventor and add it to your model manually and reflect it in bill of material. Okay, it's some steps you will do it to add your element to the 3D model of SEG and add it to the SEG library. The second way, you could, if you have a time, you could send us this standard or this spec for our technical team, and our technical team will create it and add it to SEG library so you can use it anytime. Okay. But this step takes a time because our technical team have a lot of requests, so it may take some time to generate this standard spec and add it to SEG. Around 3 weeks or 1 month to make it done.
Okay.
And it will be available on the next update of SEG.
One more question is there any option for auto dimension like nozzle name, dia, thickness, etc.?
There is an option, but we don't recommend it because it will give you a large number of dimensions, okay, and you will need the time to delete what not required. I will give you a sample, for example, for this nozzle, for example, which contains from pipe and blind. Let's create a drawing. Here, let's make it a node. And let's add another view. And from here, let's make it 5. And let's add dimensions. For example, now we will add automated dimension to this model. And let's create this just for a quick review or view. Okay, you can figure that the dimensions is let's change the scale a little bit.
Okay, this is fine. Another question is,
but it's an optional, but you will get a large number of dimensions. You will need a time to delete this and adjust this one. It's better. We recommend that you do it manually. It's better because you will select the required dimensions that you would like to notify it on your drawing.
Okay, fine. Another question is there any option for different types of internal distributor?
Yes, for distributor, for example, if we add for the internal, let's add a deflector or distributor. No distributor here, but you can make an indication for it on the drawing.
Okay.
Okay. But for deflector, for example, if you would like to add a deflector for the pipe or baffle, you will find different types of deflector. You can select between them. The same for if we add Benjamin to baffle, and this type usually used for heat exchangers. This baffle, you can use this type, another type, many different types of baffles, Benjamin baffles. You can use it on heat exchangers like this. Okay, each type, each element of those elements, each element of those, you will find many options. For example, if we select a nozzle on shelf, for example, you will find more than 15 types of nozzles. The first type, which is nozzle from pipe, which is a common one, a nozzle from blade. Okay, long weld neck nozzle according to ASME, and the second one according to BSEN, which is a European standard. Long weld neck with self-reinforcement ends. standard nozzles as a forged hub, user-defined forged hub, many types of nozzles. You can define it from this form. So each element or each main type of elements, you will find a different types inside this one. Okay. And you can figure easily that we have a wide range of elements inside the library of SEG. Any other questions for them? Hello? Fazan, can you hear me?
Hello, Fazan.
Yes, let me check. Any questions, team? If you have any questions, please feel free to ask.
Hello, I have just one question regarding the bolt. As you shown in the presentation. Hello?
Yes, I'm hearing you.
Can you hear me?
Yes, I
Yes,
can
we
hear
can
you.
hear you. Please proceed.
Yeah, actually during your presentation I seen that you have calculated the bolt length based on the flange thickness and gaskets. So do we have such feature in this software that key bolts can be calculated automatically based on the flange thickness and gaskets?
Yes, if it was making automatically, I will do it without calculating. But as you can figure, I calculate the thickness. After that, add this value to the bolt.
Mm-hmm.
Okay, is this point is clear or still need some clarification?
Yeah, please clarify a little bit more because
Okay, here in the bolts for the blind, when I create a bolt to this blind, I will need to measure the required, because this bolt not only for standard flanges. Okay, you can use it in any designed flange. So
no,
you
I am
will
talking
need
about
here.
a standard flanges.
I know what you are talking about. I'm just clarifying the point. Okay. So this bolt, you can use it for the standard and the non-standard flanges. So in the two cases, you will need to measure the required knot spacing. The knot spacing. Okay, so we will need to measure this length, which is the spacing between knots. So if we come back here to this point and open the stud bolt right here, we need to modify the knot spacing here. Okay, which is the thickness of two flanges and the gaskets, and the gasket between. Okay, so we need just measure. It's just it will not take a second like this. Measure this value. Okay, and add it to the model right here. Okay.
Mm-hmm. Okay.
Ahmed, one more question is there. In elevation view, is there any option to show indicatively like all internals such as tray, your distributors, horizontal baffle, or the vortex breaker? So can we see all this in the elevation?
Understand. I don't understand. Kindly say that again.
In elevation view, is there any option to show indicatively all internals such as tray, distributor, horizontal baffle, vortex breaker,
Yes.
etc.?
Okay. Now I get the point. On the 3D model, you can make this model as guidelines like this, and you can figure the internals easily like this. But on this option for shaded view, you will not be able. If you select a section, you can make those lines visible. And if you would like to open the drawing to check if the drawing, let's open the drawing of the general arrangement. During our selection here, you have the ability from the drawing. If we right click and from the drawing right here, if you select this type or this style, that's shaded style or hidden lines. So in this type, all lines on the drawing will be as a hidden lines. All hidden lines will be visible. But if you select this style, no hidden lines. And this style make the vessel with shaded, takes a color, the real color on the 3D model. Okay, so let's come back to the model here. All internals are appear here. So if you would like, for example, to add the location for this demister, like this, and click continue. So that's the location of this demister from the datum point that we added here. And if you would like to make this datum hidden in your drawing, just select any dimension and hide origin point to hide this one. And let's add.
Okay, Ahmed, understood.
Let's rotate this like this. And that's the datum line on our drawing. Okay. So in drawing, you can make it with hidden or visible. On the 3D model, you have an option here for view. This option for shading, you can make it with a wireframe like this, or make it shaded with edges like this. Any other questions?
Ahmed, I have one more question. Ahmed, I have one more question.
Yes.
Can we set the scale of the drawing also?
Save what?
Say a scale of the drawing. Can we adjust the scale of the drawing? Did you got my point?
Yes, sure. For example, let's make an update for the drawing here. On the setting of this drawing, we make the scale as a 19 and the location of the view. Okay, so from here, let's change this scale a little bit and move the location of this one. Let's make it 40 and like this, and let's click create and come back to the model.
Okay. Okay. Thank you.
Okay, you're welcome.
Yeah. Anything else? Anybody has any more queries? So Ahmed, I think now there is no any queries available left now.
Okay.
So you can, if you
I would like to say something at the end. Okay, Fawzan, I would like to say something at the end. Thank you for your time, and I hope that we cover your questions, and I hope this demo meets your requirements. And you can figure easily, no existing software can do all of that in minutes. We just consumed around 1 hour, okay, 1 hour to make a complicated column like this. So if you would like to make some customization, SEG will give you the ability to do that easily. And all information will be stored in your file. And anytime you have the ability to modify your 3D model and your bill of material, your drawings easily. Thank you again for your time. Thank you, Fawzan, and your team, Fawzan. Thank you so much.
Thanks, Ahmed.
Thank you so much, Ahmed.
Thank you.
Yeah. Thank you all.
Thank you all.
Okay. Thank you so much. Bye-bye. Assalamu alaikum.
Thanks. Bye.